Okay, roots of a quadratic. What shape does a quadratic make, Kara? A parabola. Yeah. Okay, discriminant. What's that? Well, first, review. Do you guys know you know 4 different ways to solve this thing? Graphing, plug that in your calculator, and you'll get a picture that looks like that. And then if you do have one of these calculators, you could solve for the zeros. And you would find, go left of it, go right of it, guess, yep, that's 2, and that's 6. But long before you're done, Will would have already factored this thing and found that out. Okay? What 2 numbers multiply to 12 and add to -8? -6 and -2. If this is equal to 0, when this quadratic's equal to 0, well, that's my definition of a root, a 0, an x-intercept. When is this 0? When x is 6. When is that 0? When x is 2. Okay, same thing. Completing the square is even funner. Okay, x squared minus 8x plus 12. When is that thing 0? Okay, we can solve for this. What do? There's nothing to factor out of the first 2 because a is 1. Okay, so I want to take half of this x term, half of 8, that's 4. I want to square it, add it, and subtract it. I still have my plus 12, but what do I want to do with the first 3? Why am I doing this? What is completing the square? I'm making this first 3 terms a perfect square. That's x minus 4 squared. And I still have minus 16 plus 12, which is minus 4. That equals 0. Okay? That tells me where my vertex is. I don't really care about this right now. I want to know when this thing's 0. So how do I solve that thing for 0? Well, let's add 4 to both sides. X minus 4 squared is 4. What would I do next, Shoni? Yeah, let's get rid of the square. Because the square root of anything squared is just the thing itself. Now if I take the square root of 4, I got to go plus or minus 4. Okay? So finally, x, get it by itself. What do I got to do to that minus 4? Add it. And x is plus or minus 4 plus 4. But what is the square root of 4? 2. So I got plus or minus 2 plus 4. There's 2 answers. It's plus 2 plus 4, or it's minus 2 plus 4. Once again, I get my 2 roots, 6 and 2. Okay, that wouldn't be the first way you'd probably want to solve it on a test, unless you like really being challenged. Okay, because I think like there's a lot less writing here, isn't there? Okay, yeah. All right. Finally, yesterday's stuff, quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. When I was in grade 11, did I tell you this already? Yeah, I had to walk to school. It was uphill both ways, right? 3 feet of snow for like half an hour. That was just to get to the bus stop, okay? We lived in a mud puddle in the middle of the road. I had to memorize that. Okay, we weren't allowed to write it down. I guess some kids wrote it on the desk and top of their shoe and other things, right? The back of Will's glasses right there in the corner so you can see it. There it is. You didn't hear that from me. Okay, but anyway, we didn't have graphing calculators. I don't know, they might have had it. But it took up the whole room and it cost $1 million, right? IBM made it. Anyway, The one time my teacher actually left his desk area was when he was trying to say this. He actually left this area and walked around the room saying this about 9 times. Don't make it sink in our head. Yeah. Kind of like this. Serious. No teacher ever left the front of the room when I was a kid. Some of them came in, sat down. They did not leave this seat. You had questions, you go up and see them, right? I'm kind of like ADD. I gotta move. I gotta keep moving, right? Anyway, all right. What is B? What's A? That's what we want to do. Here's my quadratic. A is 1. B is -8. C is 12. Mr. Whitelock, if you're listening, you were a great teacher. I really liked you. Okay. Plug them in. What's -8? 8. Plus or minus the square root. What's -8 squared? Don't forget brackets. It's not -64. Positive 64, right? Minus 4 times 1 times 12 all over 2 times 1, which is 2. Okay? So 8 plus or minus, what's just the stuff under the radical sign? 64 minus, is it minus or plus? It's going to be subtract. It's a good idea just to look at the sign of this stuff to know if you're adding it or subtracting it, right? Okay? So someone yesterday tried to just put this in their calculator. Wrong. Okay? Garbage in, garbage out. You're going to subtract. What is this? 4 times 1 times 12, 48. What's 64 take away 48? Oh, that's nice. But again, I know this thing factors, right? So as an exact answer, it's going to be a nice integer, isn't it? Okay? So I got 8 plus 4 all over 2. I have 8 minus 4 all over 2. What's 12 over 2? 6. What is 4 over 2? 2. Same thing, right? 4 ways to do it. You got to know all 4 if you want a good mark. Okay? All right. So all we're going to do today, though, is see what the heck this thing is. All right? What's a discriminant? How does it help us? Okay, let's go to here. I guess I could have done this as a little lab. Where did it go? What happened? There it is. Oh, look at that. I inserted a blank page where I didn't want one. I didn't know I could do that. Weird. Learn something new every day, right, guys? Lifelong learning. I could have done this as an investigation. This is what I want to do. Put in my highlighter. Okay. Here's the weird wording. The nature of the roots, yes. Math is really natural to some people, like Reese. Okay? To others, it's like pulling teeth. Okay? The nature. Let's just be at one with our math today. Okay? Let's be holistic. Everyone got any granola? Forget it.
Well,
all right.
I don't know if this counts.
Sure, that's granola bar. That's good. Okay? Got your Birkenstocks? You got your Mandels? All right. This is the weird wording. I'll say this again. All right. Let's just see what's going on here. Here's a quadratic. It makes a parabola. All right. I'm going to use quadratic formula to solve this. Minus 6. They've already started this for us. Okay. Plus or minus -6 squared is 36 minus 4 times A. We should write it. Already did that, but anyway. Okay. 1, C is 5. Okay. So 36, am I adding this or subtracting it? There's only one negative. I'm subtracting 20 from 36. That is 16. So I got 6 plus 4 over 2, and the other root is 6 minus 4 over 2. So what's 10 over 2? One root is 5, the other one is 2 over 2, 1. All right, and look at that. They already got a picture for us. If you were going to graph this, if this wasn't there, another point we might like, okay, I know it goes through here, I know it goes through there, is the y-intercept, right? How hard would that be to get? What happens at the y-intercept? X is 0, 5. 0 and 5. 0 and 5, there it is. Okay? So you kind of know how wide one side is. And again, these are always symmetrical. Right? So if you know what one side looks like, you could find the other side, and you'd have a pretty good rough sketch of this thing, right? Just by 3 points. Okay. Equation number 2 looks, well, it's different. And other examples in years past look pretty similar. Anyway, let's see what's going on. A's 1, B's negative 6, C is 9. Plug this stuff in. Again, I have 36, negative 6 squared, minus 4 times 1 times, now it's 9. Okay, 36 minus 4 times 1 times 9, Jake? Yeah, 36, take away 36. What's the square root of 0? Yeah. So I got 6 plus nothing over 2. And 6 minus nothing over 2. What are my, I'm going to emphasize this, Meryl. What are my 2 roots? 3 and, what's the other one? Which is 3. 3 and 3. Right? Like I said, it's like pulling teeth with some kids. Okay, 3 and 3. It's the same root. But I'm emphasizing this. Is that 2 roots or 1 root? Yeah, so we call this a double root. Okay?
Oh,
20% of you will get a root canal, by the way. It's not a very pleasant thing.
is this one where they overlap?
Talking about teeth. Okay. What does this thing look like? If you put that in your graphing calculator, there's the point 3, and there's the other one, 3. Does it really cross the x-axis? It touches it and bounces back up. It's still called a root. It's still called an x-intercept, even though it doesn't really cross the x-axis. It just touches it, okay? It's still a root, still an x-intercept, okay? There's still a solution. It's called a double root because every parabola has 2 roots. This one happens to be the same, okay? So we're saying it twice. All right, let's look at the last one. Negative 6, once again, A's again, 1 again, C's 13, 36 minus 4 times 1 times 13. I'm going to subtract 4 times 13. What's that? How many cards are in a deck of cards? Yeah, it goes from ace to king. That's 13 in each suit. There's 4 suits. Anyway. 36 minus what? 52? Now who's going to want to put that in their calculator? Shelby? What would it say, Shelby, if you put that in your calculator? Yeah. Why is that? Because you can't take the square root of a negative. So you get universal. Then that'll be 4i. For imaginary. Have you done this? No? Okay, I'm going to teach Meryl something today. 4i. I stands for imaginary. Yeah. Anyway, you can't do this. You're not a big kid. Only you teach this to big kids. You can handle the truth. Okay? So, all we're going to say is you can't do it. And hey, if you put this in your graphing calculator, how many times does it cross the x-axis? You got 2 times, you got 1 time, and you got no times. Okay? Or 0 solutions until you know how to get the solution. Okay? Okay? So, the roots are, there's another way to say this. Because again, there's an argument, well, there is roots, but they're not real. Okay? This is what professors like to get together with and have meetings about for weeks at a time. Yeah. Okay? All right. So, here's this wording again. I can't tell you this on the test. Okay, focus now. I can't tell you this on the test. If you see a question that has this wording, what is the nature of the roots? What word you got to think?
Well, now I'm going to associate nature with Reese, because you said something.
That's not helpful, is it?
Not really.
Um,
I'm serious, that's all.
all right. Nature of the nature of the roots, discriminant. That's what they're talking about, okay? So, in equation 1, what happened? We had 2 different or distinct roots. We're going to give you all sorts of weird words here today, okay? They're real and they were unequal. How can we word this again in layman's terms? What's another way to say real and unequal or distinct? 2 different roots. Okay? Does that say the same thing? Real and unequal. Okay, 2 different roots. Right? That then crossed in 2 different spots. In this equation, they were real and equal. Okay? What's another word for equal? Same. There's 2 roots. We're just going to say they're the same. Okay? And in the last one, you can say there was no solutions, no roots, but again, they'll argue, he didn't know what he was talking about, that grade 11 teacher in second year university. Oh yeah, there's 2 roots. They're just not real. They're there, but they're not. Okay? Okay, so it might say that, it might say no roots. All right, what's the discriminant? There it is. Have you seen this before? Does that look familiar? It should, because you've been working with it all yesterday. That's the stuff under the radical sign, right? Minus b plus or minus the square root of b squared minus 4ac all over 2a. Hey, looky there. That's the discriminant. So you don't have to memorize it. If you got the formula for the quadratic, and yeah, it's in your formula sheet, it's there. Now, does it say on your formula sheet, the discriminant is, no, you got to know this. That's the discriminant. The stuff under the radical sign. Okay? So, complete the table using the calculations from the investigation. This was equation number 1. That was the first one. What happened? What was the value of my discriminant here? B squared minus 4ac. Okay, that's everything under the radical sign. That was 16, right? And what happened with my roots? I got 2 unequal, unique, distinct, 2 different roots. All right? So, b squared minus 4ac was 16, right? The nature of the roots. What were the roots? I had 1 and 5. They were real and unequal. Or you can say 2 different roots. Okay? This was equation number 2. That was the second one. Remember what happened? I don't. Let's go have a look. All right? What was the value of my discriminant? 0. And what happened? I got 2 equal roots. Okay? So this was 0. I got 3 and 3. And I got same roots for real and not unequal, but equal. Equation number 3 in our investigation. What happened? Do we remember? Well, let's look again. Can you take the square root of a negative? No. So if your discriminant is less than 0, that's what's going to happen. It's going to say, can you take the square root of a negative? If your discriminant is negative, you're always going to have unreal roots. That doesn't mean they're cool. That means, as for our purposes, there are none. Okay? All right? So here, this thing was what? Negative 16. So a non-real. Okay? Grade 11, I can say no roots, no x-intercepts. It doesn't cross the x-axis. All right? So this is more the table we want. This is kind of what happened. No roots. Now, they go and screw this up and put this in a different order, of course. This was equation 2 when it was equal to 0. Okay? If the discriminant is equal to the 0, then the roots are real and equal, right? Same. If it's greater than 0, they're real and unequal, right? Two different roots. That's better, more layman's terms. And if it's less than 0, can you take the square root of a negative? No. Non-real. Okay? This is what goes on. Is that on your formula sheet? You got to memorize that. Okay? It's not bad because this one should kind of make sense. You can't take the square root of a negative. Okay? The other two you got to remember. If it's equal to 0, you get 2 of the same roots. You get a double root. If it's greater than 0, you get 2 different roots. Okay? Got to remember it.
Mr. Watson?
Yep.
So basically, like, if it's in the vertex form, anything with a value of P and Q have a value, but both of them have a value greater than 1, then it's going to be no root.
Not necessarily true, because what if the parabola is negative and it goes upside down? Then you have 2 roots.
Okay, as long as that's true.
Okay. Don't think that doesn't help you. No. All right, couple of examples. When you see that wording, you got to know what to do. Today it's easy because you know this whole lesson's discriminant, right? You're going to get that on the test in, 6 days? No, 7 days. Monday's the holiday, not the Friday. Okay, 7 days. And it's not going to say, use the discriminant, find out what's going on. You got to remember it, okay? So, without solving or graphing, what's A? 6. What's B? -1. What's C? -1. What's the discriminant? Just b squared minus 4ac. Let's see what's going on. Just plug the stuff in. -1 squared minus 4 times 6 times -1. Okay? That's 1 plus 24. That's 25. What do I know about the roots of this quadratic? This you got to stick in your head. It's greater than 0, the discriminant. So I get 2 different roots. Okay? Therefore, 2. Now the book's going to say, right, the other wording. I'm happy with this. If it's a written question, 2 different roots. If you want to go 2 real and unequal roots, well, that's fine too. Okay? I know you hate having more than one way to answer it, right? So we found out yesterday. This is the discriminant. Is 25 greater than 0? Is 25 greater than 0? Yes, it is. Therefore, okay, either this is going to happen, that's going to happen, or this is going to happen.
Wait, so if it ends up to be 0, then it's real?
Yeah, that's what it says.
So your only answer can be 0 for that?
Yeah. Okay?
I get that.
All right. What's A, B, and C here? Who can I pick on? Turn A. Way down there, quiet in the corner. What's A, B, and C? Do you see what it is? Oh, you little trickster. Yes. A's 1, B's -8, and C's 16. Everybody happy? Okay, she rearranged that in her head. Okay? I recommend you writing it like this, because it's so easy to make one little sign mistake and then everything's wrong. Okay? A is 1, B's -8, C's 16. All right. There's the discriminant again. So that's -8 squared minus 4 times 1 times 16. 64, what's 4 16s? My discriminant is equal to 0. What does that mean? Yeah, 2 same roots. That works. Okay? 2 equal roots, same thing. Double root, okay. A's 5, B's 2. Anyone want to take a guess what the answer of this example is probably going to be? B squared minus 4 times 5 times 1. 4 minus 20 is what? Minus 16. My discriminant is less than 0. Uh-oh. What does that mean? Well, look on your table. It's right there. If this thing's less than 0, I get 2 non-real roots. This is worth saying again, because in my quadratic formula, can you take the square root of a negative? If you just try to solve that, it's going to say error. And then you're going to go, what? Something's wrong with my calculator. No, it's just there's no roots. Okay, you're trying to solve something that doesn't exist. Okay, 2 non-real roots. All right, now let's just step it up a level in ability. This is asking you the same thing, it's just a little tougher. Okay, it's a higher level of understanding of what's going on here. For what value of m does this quadratic have real and distinct roots? What's another word for distinct? Different. What do I know if it has real and different roots? What do I know? I know the value of the discriminant is greater than 0. Okay? This one's a little backwards. That's where you got to start. Here's my quadratic. What's A? 1. What's B? -8. What's C? C is m. Plug the stuff in. -8 squared minus 4 times 1 times m has to be greater than 0, because I got 2 different roots. So 64 minus 4m is greater than 0. What values of m will this thing work? I got to solve it for m. Okay? So minus 64 both sides. Do I flip the sign if I subtract 64? Just if I divide or multiply by a negative, right? I can add, that's fine. All right? So minus 4m is greater than minus 64. How do I solve this for m? Divide by a negative. What happens to my sign? Yes. All values of m less than or equal to, how many times does that go in there? Positive. If m is less than 16, I have two different roots. And if it's not, then something else happens. Okay? That's what m has to be to have two different roots. Okay. Having said that, what does m have to be to have two of the same roots? What do I know? What do I know about my discriminant if it has a double root, two of the same root? This is equal to 0. Solve it. But hey, hang on. Didn't I already just do this? What is b squared minus 4ac? You see this thing here? Yeah. You want to do that all over again? Be my guest. But I like cheating. 64 minus 4m. Now it has to equal 0. What would m have to be, do you think? It's minus 64 minus 16. Could it be 16? Divide by negative 4. How many times is 4 going 64 again? Hey. Any guess what the last one's going to be? Okay, so what did that say again? If m is 16 in this guy, I'm going to have two of the equal roots. This guy is going to look like what? I don't know where it is, but he's going to touch right there and go back up. Okay? It's the double root. There's two roots, it's just the same value. Hey, isn't that kind of like y is x squared? There's two roots there. One of them 0, the other one's 0. It's a double root. Okay, just touches the x-axis and goes back up. That's still a solution where y is 0, right? So that's still a definition of an x-intercept. It just doesn't cross it. All right, last one. If it has non-real roots, what do I know about the discriminant? It's less than 0. Have I already done this? Yeah. 64 minus 4m. When is this less than 0? When is minus 4m less than negative 64? When is m greater than 16? Okay? So a little more involved. That's it. Number 4, 5, 6a, 7, and 8. Better? Oh, wait, I know what you do in Europe. You do this. You don't? You put a line through. Oh, no, wait, that's a 7. It's not a bad idea. Here's what bothers me the most. Kids in like grade 9 go 2z, and they wonder why, and a couple lines later it's like a 22. Put a line through the z.